Okay, welcome everybody. My name is Pierre-Yves Ricau, or PY. I work at Square. This is my Twitter handle, and today I'm here to talk about LeakCanary 2. So who's heard about LeakCanary before? A show of hands. Oh, cool. Almost everybody. So, you know, it's an open source library from Square that we released in 2015. So that was the blog post announcing it. And the core idea was that sometimes in your VM, you stuff some objects around and you forget to clear some references and they cannot be garbage collected, right? And for example, an activity that you put in a static field, and we all know that's bad, and these things, they accumulate, and over time, all those tiny memory leak end up making the VM run out of memory, and then it crashes with an out-of-memory error. So the idea with LeakCanary was to collect references to these objects and then check with weak references if they were not garbage collected. And when that happens, take a heap dump, which is a copy of the memory, store it on the file system, and then analyze that automatically and show you why the instance is retained in memory. So that was 2015. And what that did is really it helped us bring the rate of out-of-memory errors way down, and I hope it helped the community. But as we got better at fixing all the simple leaks we found, we also got better at writing complex code. We have a ton of RxJava, we added a whole bunch of things, and all of a sudden we had really more complex leaks that were actually harder to understand. So on top of that, LeakCanary 1 had a number of shortcomings. So the number one problem is, so what is this? On the right side, you have a leak trace. So I kind of made that term up. A leak trace is kind of like a stack trace. What it is really is the shortest path from the GC roots, like static fields or threads, to the instance. So it's how this instance is leaking, essentially. And so on that side, you have that. And on the right side, as a UI, on the right side, it's the same thing, but as a string. But even with the color, which kind of helps understand what's going on, and removing the package name, it's still hard to know where the problem is, right? I look at the thing on the right hand, and I'm like, well, so what I did back then is I sat down with a bunch of colleagues, and I asked them, so where's the problem? And most people would just, like, find a class they know, like here would be agenda fragment. Oh, that's mine. It's got to be there, which has nothing to do with the actual problem. This is actually an Android X memory leak with menu items. So it didn't really help that much for complex leaks. So you may have noticed that this says agenda fragment, and the package names are Android makers. This is I use the Android makers app to test older versions of LeakCanary and newer versions of LeakCanary. Don't worry, all the leaks have already been fixed, so you're good. Anyway, so that UI was kind of confusing. Now another problem, and I wonder if you've been using LeakCanary, you might be frustrated with that. You know, when it finds a memory leak, it does a heap dump, which is just a call to an Android API, which copies the entire memory to the file system, and that takes a while. So the entire UI is freezing when that happens. Which, if you're trying to do something, like you're developing and you're trying to test a feature, and then in the middle it gets in your way, it can be a little bit frustrating, right? Now, it's also kind of slow. It slows down the app. Once it's done with the heap dump, it starts analyzing it, and that kind of slows down the app. And then there's another problem. So you have memory leaks in your code. I'm sorry, even if you wrote the best code ever, you do have memory leaks. It's just a kind of a fact of life. It's really hard to avoid them. But it's not just your code. Android X has leaks. AOSP, the Android source code, has leaks. And those leaks, it's kind of hard to do anything about them, right? But we can't know before we've analyzed the heap dump. So, for example, in Android P, there was, I think it's P, there was a new leak in view group and in view location holder. And all of a sudden, everybody using Android P had freezes all the time from LeakCanary. So what do you do about that? Because, of course, it's going to be fixed eventually, but do you just stop using P? Do you disable LeakCanary? What do you do? So that's the concept of excluded leaks, is those leaks that you really can't do anything about because it's not the code that you own or can change. So you kind of like, the leak is still there, but you kind of say, well, I guess that one I don't care about. I can't do anything about it. But the other thing is those leaks, they keep happening over and over, right? Like the view group one. And so as you're trying to develop, the app would just show, dumping memory app will freeze, and then it goes away. You're like, whew, and then dumping again. And you're like, no. And so that makes people angry. I've seen people being angry at LeakCanary and just disabling it. I'm like, okay, I guess you don't care about leaks, but it's understandable because it's kind of painful. Another thing that was not that great is the whole setup. So parsing the heap dump it required a lot of memory. It uses something called perflib, which is from Android Studio. So it's essentially code from Android Studio, the memory analyzer, that's extracted out and shipped inside LeakCanary. And that reads the entire heap dump. So we use a lot of memory, which meant that we had out-of-memory errors when trying to analyze the memory. And so that's kind of annoying. And as a result, what we did is create a separate process for the analysis so that it runs in its own process and it has more memory available. But as a result of that, the application class is instantiated in both processes. And so you have your app code running in the LeakCanary process. So that's why we ask people to check if they're in the process and just do nothing and uncreate in that case. But that's annoying to write all this code. And then there was like a bunch of things with dependencies. You have a no-op dependency because you might not, you want to call LeakCanary.install and you want it to do nothing in your production app. So in production you have a no-op. But then when you're writing code in unit test, do you use the no-op? Do you use the real one? It was a little bit confusing. And then the APIs were not always great. Like, this is all the code you have to write if you want to be able to say, oh, now I stop LeakCanary, I don't care, and now I re-enable it. And it's way too much, because it should just be like, turn it on, turn it off. And finally, I think the most important one was the logo was not the most beautiful logo. I mean, maybe you came to love it. Maybe you came to hate it. The story of the logo is that as I was just about to release LeakCanary, the first thing I did was I was like, okay, I need a logo. I'm going to search Canary on Google Image. I picked a picture of Canary and I did the contour of it. And then I went to the Android Asset Studio from Roman Nurik and I looked for like a shield icon. I put an exclamation mark, the Canary shield icon. I was done. It was very pixelated. And therefore, I got one contribution from Romangi right here. Woo! He made a vector. Pretty exciting. Yeah, he made this huge contribution to LeakCanary by making a vector icon, which we've had since. And it was, I really appreciated that. But the truth is, the original one was ugly already, and this is still kind of ugly, even though it's a nice vector. So I sent a tweet asking like, okay, I'm working on LeakCanary 2. What would be nice? One thing was like, oh, deferred leak analysis while the app is not working. And that's the idea that I'm developing. Don't bother me right now, right? Like, I just, like, tell me later. Another one was kittens. And it's cool. And Michael, maybe we'll have kittens someday. Another interesting suggestion was, in release builds, I actually want to know how many leaks I have, even though I'm not doing the whole heap dump and analysis thing, like using weak references to tell me how many activities are leaking. And finally, one that was kind of interesting was that when you opened up in LeakCanary every element, you'd get this weird dump of strings that I added as a hack to understand the state of the objects, and it was super ugly. And I'll get back into that a little bit later. So LeakCanary 2. So we're done with the problems. Now, we'll talk about like what's different. And pretty much everything's changed. Starting with the most important change, right? The logo. Yeah. So what is it? It's a dead canary because because the whole name LeakCanary was canary in a coal. It's the story of a canary in a coal mine. So the mine workers they used to have canaries with them. If there's a gas leak, the canary would die, and the workers would know to run for their life because there's a gas leak essentially. So the canary dies before they die essentially. So that's what LeakCanary is. The logo was made by Felicity Browers, who is a designer at Square and a good friend, and I like it a lot. I made it into a T-shirt. I'm not selling the T-shirt, but the assets are there. You just need to ask me. I can send them to you. More importantly, we had over the last month, which is kind of when most of the work happened, 14,000 additions and 9,000 deletions. And we all know that lines of code really, are important for demonstrating work. So why are we adding 14,000 lines and removing 9,000? Well, mostly because it's full Kotlin. It was just full Java before, and everything was converted to Kotlin. That's thanks to Brandon Cheng and Colin March, and they did it all over like the course of a week. It was converted by 200x as well by Brace Gabin, and so the whole idea was, well, we're going to go with version 2. We're going to break all the APIs. Let's just put everything in, like everything that's nice and latest. Not new dependencies, but more like let's upgrade to everything. Okay, so that's the cool stuff, but you don't really care. I mean, it's nice. So let's talk a little bit about a new feature that's going to be interesting. So I mentioned that it's annoying to have this thing on repeat. So one of the big changes is that LeakCanary is able to find many leaks in one heap dump. And what that means is that we, by default, don't dump the heap on every leak that we find. We wait for a threshold, and the default threshold is 5. So you're using the app. There's 1 leak, 2 leaks, 3 leaks, nothing happens. When you reach 5, then you get the logo and everything. So the idea was, if you have some of the Android framework leaks or the whatever leaks that are there, they're going to be leaking, but you still have some margin for your own leaks before, and so you don't get this constant nudging. The other thing that happens though is as soon as you press home, as soon as you go, the app goes in the background. Immediately, if there's 1 leak, it triggers. And so the idea is, well, if you're doing something else and you're not going to see that the UI is freezing, we might as well just go and do it. Also, there was a bug where if you let every leak, we used to be stored as a file, every result, and so when you had hundreds of them and you didn't delete them, when you loaded the UI, you would just read like all those files at once on the background thread, but still you'd wait like a long time before seeing the list. So we switched to SQLite. It's much faster now. But as we are now finding more leaks in one heap dump, the analysis is even slower. So that's not really cool. Okay, so I want to talk about something else that's kind of interesting, a new feature. So that was the first feature, like many leaks at once. In 2017, I gave a talk at Devox, and I tried to explain how I was personally analyzing leaks. I demonstrated how I would look at a leak trace and try to understand where the problem was. And the way that I was doing it, for the most part, was trying to find which part of the leak trace is the potential cause. And the way I did that is I reasoned about the code, the things that I was looking at. So, for example, here, you can see that the third row is example application, right? So it's the application class. You know the application class is always there. You know that it's not leaking, which means the leak is further down. And similarly, well, the activity has been tagged as destroyed and is leaking, so you know that the problem is in between. And you can reason more and more about these things. Like, for example, you can say, well, this view is detached, so probably it should not be in memory anymore. We're not using it. And there's for example, we use Mortar, we use Flow. All of these objects have state, and we can scan that state in the heap dump to make decisions and reason about, is this supposed to be dead or is this supposed to be alive? So this is, for example, with a view. We can look at a view and say, well, it has m-attach info that is null. You probably never saw this because it's an implementation detail. But m-attach info is null when the view is detached, and it's not null when the view is not detached. So just looking at these things was how I was figuring out the problem. And what I said in that talk is that it was boring to do always same thing again and again and again. And that's actually why I was dumping all of the fields, like the ugly dump of strings, because I could do this and look for things. And I said, well, we could probably automate it. And immediately Jake Wharton filed an issue, like, yeah, you should do that, like, just automate it. So, nice. So I did that. And so that was in LeakCanary 1.6. And so we have this idea. So this is an example for an activity. If you find an activity in the leak trace, if it has a field called mdestroy, it may not have one because Samsung or because future of Android, so we never know. But if we have one, then we check its value. And if it's string true, because we're living in this weird world of not the JVM but analyzing a heap dump, then decide that it should be destroyed and it should be unreachable, and otherwise say it should be reachable. So the API isn't great, and I intend to, it's still there in 2.0, but I intend to change that. But so in 1.6, you started seeing this. Little squiggles, they're like basically the UI from Intellij compile errors, right? And the idea was to say, oh, over here, the problem is only one of the red things, right? So that's cool. Now, what I didn't realize was that I was making all these things based on information that I had by scanning the heap dump, and I knew how it worked. So when I see, oh yeah, the button is, the request, the button is not part of is not leaking. I knew that because I know it wasn't underlined. Basically, I knew exactly how it worked under the hood, and I couldn't understand how LeakCanary came to this conclusion. But I could because I wrote the code. And most people had no idea. They're like, cool, but how do I know that I should trust you? Well, you should trust me. But that was one of the main issues. So this is what it looks like in LeakCanary 2. So it's a whole lot, and bear with me. This is like just fresh out, and the UI needs like probably a little bit of working. But the idea is that we're going to surface more information. So at the top, we're telling you, okay, this is a handler thread, and it's not leaking. We know because it's a thread, it's a GC root, okay? Oh, by the way, the thread name is queued work looper. So this is a new feature of LeakCanary 2 where I implemented that like yesterday morning. So it's fresh, it may be broken, but the idea is that we can add labels to any instance. So for example, for a view, we could say the view ID is r.id.foobar and get the actual resource name. So it should help you understand where the problem is, or what you're looking at least. The second one, okay, it's not leaking because it's a class loader. Class loaders are not leaking. The third one, okay, so it's an array of objects. We don't know about it if it's leaking or not, but we know it's not leaking because below, the thing that's right after is not leaking. So we don't have to care about this one. Okay, further one, okay. The scheduled session helper is not leaking because it's a class. Actually, this is not an object, this is a class. And maybe that needs to be more clear in the UI. But it's a class that has a static field called toast. And then toast, we don't know. So because we don't know if toast should be reachable or not, we can say, well, the problem is probably like starting here. And then same thing, toast has an M context field. And we don't know, like, can we make any deduction about whether the context should be, well, we don't know if toast should be leaking or not. It's hard to know when you look at a toast state whether it should be in memory or not. I mean, maybe there's a way. I just haven't implemented the inspector yet. And then the activity we know because it's destroyed. So from that, we can kind of like zoom in and we say, well, the problem is one of these two. Usually, toast is probably correctly implemented. And so that really tells you like immediately like, oh, yeah, I know the toast field in scheduled session helper is a static field. So it probably should have been cleared, and it wasn't, and we have a leak. And so scheduled session helper is a Kotlin object, by the way, so it's a singleton. So the leak was fixed and merged, and your app doesn't have the leaks anymore. Which is, I mean, I submitted a hacky fix, which is on activity on destroy, tell the schedule session helper to forget about the toast. So back to this. So we have a leak with the toast, right? So every time we show a toast, we're leaking the the context of the toast, right? And that context, which is an activity, might have some views, might have some fragments. And LeakCanary is watching activities, fragments, and fragment views by default. So what happens is you actually have a bunch of leaks, right? And they're all about the same problem. I have this toast field. But they're all going to look different. Maybe it's a different object that's maintaining the schedule session helper in memory. Maybe it's a different activity class, different things. So as we were playing with this more, I realized, well, hold on. There's one problem here, right? It's 3 different leaks, different types of leaks, but there's only one problem. It's the toast field, right? And really, when you look at it, you already see the pattern, right? It's like, well, the part in the middle in red is the same for everybody. So what can we do? Well, we can group them. And so that's one of the key ideas of LeakCanary 2 as well. It's pretty stupid, but it's like, okay, take all of the red parts and just put them as a string together, and then compute the SHA of that. And I'll give you a hash, a SHA hash, and that's going to be a group ID. And so if it's an excluded leak and we've recognized a pattern of a class that we don't care about, then we use that as the hash. So that enables us to build a UI where instead of having 200 leaks, you just have 2. The 2 types of leaks that you have in your app. And then you can see there's group number 1 has 11 leaks and group number 2 has 12 leaks. They're sorted by the latest. Anyway, that should really help with understanding how many problems you have in your app instead of, well, I don't know, it just keeps happening, but maybe it's just always the same. And you can use the counts to say, well, this one is happening a lot, so we better look at it. All right, so once you click on a group, this is like a UI I put together in 5 minutes, so bear with me. But essentially, at the top, you have the summary of the common parts, and then every instance of the leak, and then you can dive in. So that's different. So because we have groups now, and we have one group at a time, there's a separate page where you can see all of the, essentially, heaps, all of the heap dumps and their analysis. So if you would dive into one, then you would see a set of groups for that specific analysis. So you kind of have these 2 views of the same data. So that's it for grouping. I think this is going to be really interesting for having a better understanding of how many leaks you have. Now let's talk about this tweet and this idea of in release builds. I mean, I don't know if that's exactly what Sayed meant, but essentially in release build, I want to know how many leaks I got. Maybe I can't do the heap dump and the analysis, but at least I want to know how many leaks I've got. So there's a new library for this, because essentially that's what LeakCanary does. So I extracted all of that small code that does the reference watching, and it's called LeakCanary. And that's all you do. You say, hey, so the API might evolve, but the idea is, okay, we got an out-of-memory error. Let's count how many retained activities we have. And then you do that, and you could add that as metadata to Bugsnag or Crashlytics. I'm hoping that it's going to be useful. I haven't really field tested it yet, so we'll see. It's an alpha that's being released, by the way, so I'm counting on you to test it. So I mentioned that before. What is the most common issue with LeakCanary? I mean, most common, I mean the one that got like so many people like adding comments and saying, the error issue is out-of-memory error. The out-of-memory error while trying to analyze, and it's been a while, and we try to work around it, try many ideas, including using a separate process, which definitely helped. The thing is, what's the core of the problem? The core of the problem is I was being lazy, really, because when I tried to make LeakCanary, I wanted something that worked, and I wanted it fast. And so I needed something to parse the heap dump. And I said, I don't want to write a heap dump parser, so I need to find a heap dump parser. I found the code from memory, from Eclipse Math, and then later Google released Perflib, which is actually Android Studio, which contains Perflib. And because that's made for Android, it was way better, because I really didn't have to do anything. So I was like, great. Because the Eclipse one, it was like a patch version of the Eclipse one. So I used Perflib. Now, perflib is meant for Android Studio, which means it doesn't care about the memory it uses. You know that Android Studio likes to use your memory, right? You've seen so it's not really a problem there, I guess. It has a few other issues, like depending on Trof4j, which is under the LGPL license, so it could be annoying for some people. And it loads most of essentially what it does is it reads the heap dump, loads all of the objects in memory. It doesn't load their property, that's kind of lazy, but at least loads the entire classes and objects in memory. And then it navigates the graph to find interesting stuff. So that being said, objects are like hundreds of thousands of objects in one heap dump, so that's a lot. So what is the solution, right? It's to write a new heap dump parser. And I did not want to do that. I've talked about doing that for 2-3 years probably. And I've said, and I try to find them, like, do you want to write a heap dump parser? Do you want to write a heap dump parser? I was trying to get people excited about it. And some people have, actually, and there's been some interesting stuff. Gerard wrote a demo that was interesting where we could learn from that. But eventually I realized I had to write one from scratch. And so I did it. So the key idea was, instead of loading everything in memory, we're going to scan the heap dump. We're going to build an index, and then we're going to jump around on the file as we need based on the index. And therefore, in my mind, it would be probably slower, but much better for memory. And then I decided to build it on top of OKIO because it's a Square library and it's very efficient in theory. So, which, I mean, it is, but you never know. So, like, you know, it essentially looks like that using OKIO. It's like, okay, I have a file, give me an input stream. Okay, to use OKIO, you need a buffer, and so you do input stream.source.buffer, and you get your buffer source, and you can start reading stuff from it. There's one trick here, is because I knew I needed to jump around on the file. That's not something that comes standard with OKIO. I took the input stream and retrieve the NIO channel. So it's something from the JDK, which lets me then do this. Essentially, when I want to jump to another place, instead of reading continuously, I just say, hey, OKIO, forget about what you got. And then I tell the Java NIO channel, hey, you're here now. It just moves, and then OKIO resumes reading like normal. Cool. So now we know how to read bytes. How do we read a heap dump parser? Well, there's a spec, fortunately. It's very nice if you like to deal with bytes. Okay, this is a U4, and this is an ID, and blah, 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 and it goes on and on and on and on and on. And so it's a lot of stuff. Most importantly, it's for the JDK, for the Java VM. Android heap dumps are different. So the only solution here was actually to go look at the implementation perflib, and that basically is the reference implementation that shows how Android works. So who knows what a heap dump look like? Who's seen a heap dump before? That's what a heap dump look like. Right, and you can totally understand what's going on here. So I actually built this into, I wanted to explain for this talk what a heap dump looked like, so I built this into LeakCanary. So now on analysis, you can render the heap dump and see this. I don't know if it's going to be useful at all, but I just think it's cool. Each pixel here represents 4 bytes. And so let's look at it. So what we see here, yeah, it's pretty obvious, right? So the first thing is what's called hprof strings. So class names and field names, they're not like normal string objects, actually. They're stored at the beginning of the heap dump. And they're stored essentially in this way. So this is how we read a heap dump. We say, OK, just reading while, you know, forever. OK, you get a tag, and you say, what is this? Oh, this is a string. And so we when tag. Right? And so we have a tag and the length of a tag, which is the length of the content that follows. Oh, if it's a string, I know that I have to read an ID, which is either 4 bytes on 32-bit systems or 8 bytes on 64 bits. And then I need to read a string that is the reminder of that length that I had. And then that's my string. And so I have a string and ID. The next thing is class names. It's this green stuff. It's the second entry. And so what's a class name? It's a bunch of things, but for the most part, it's an ID, the ID of the class, that points to the ID of a string. So if you find a class, which we'll find later, and then you look at its ID, then you have to go find this entry to find the corresponding string ID. Then you have to go read the string ID, then you get the string content, and that's how you find the class name. So now we can look at the rest. So the yellow stuff is stack traces, not that interesting. Let's see. So I had some notes here because it's a little bit tricky. The red stuff at the top which is mixed with pink. So red is strings. So strings are actually instances that I marked in a special way because I found them interesting to look at them. And so you have essentially a string object, which is just like, oh, I'm an ID, and here is a pointer to a byte array where my content is, and it's usually followed by that byte array, which is an ID, and then just a bunch of bytes. And so you can see that, oh, at the top you have a lot of red and pink, and that's just all the strings of the app heap. And so the cyan color at the top is the color of the app heap, which is where your instances live. And then after that, you have very clearly just like a lot of pink, but with some green. The green is the class content. So essentially, you have all your classes definitions in there. Yeah. And then at the bottom, you have some deep purple, and that's more like the instances, the other objects. And then if we keep scrolling down, we have kind of, very obviously kind of similar but different. Because this time, at the bottom, you can see that it's not cyan, it's a darker blue, and so it's a different heap. It's the image heap, the heap that's created when the phone boots, and that's where all the shared content lives. And so one thing that I found interesting and kind of curious is there's this. So we see all the pink and red stuff, and that's basically all the strings in the image heap. But in the middle, there's some orange. Let's zoom in on the orange. What's this orange? Well, so orange is car array. So it's still string objects. You still see red and orange, but weirdly. So here's what's going on. String.java used to have a value field called car array before Android 26, I think, Android 8. And in Android 8, they removed that, and string is actually implemented by native code. So you don't know where the car array actually lives. But it turns out it is sometimes a byte array and sometimes a car array. You'll never see that because you're using the Java API and you get a nice car array and all that. 90% of the time, it's a byte array. But in some of these weird, and I try to dump them to look at, and they're just weird strings, like random characters and all that. They're just cars. This is not useful to you, but I just found it interesting. Anyway, you can find this in LeakCanary, and you can export as an HQ PNG and do presentations on heap dumps, which I hope you do. So I profiled an instrumentation test that was running LeakCanary with perflim. And so this is pretty much how much memory it uses, like about 140 megabytes. And it does the whole thing after heap dump, but like the whole analysis in 35 seconds. So I iterated on my new parser, and I run the same test. And this is how long it takes and how much memory it uses. So we're looking at 30 megabytes. So we lost 110 megabytes. And we're looking at 5 seconds instead of 35. So I'm pretty proud of that. Yeah. The memory I found sometimes went up to 10 times less memory used and 6 times faster. There were like a lot of optimizations to get there. I think it would be an interesting talk in and of itself to go talk about LRU cache and sparse arrays and bit packing and all of that. But we don't have time for that. So we're going to keep going. So the new parser is a game changer. It's much faster. It uses way less memory, which means we don't need to use a separate process, right? So because we don't need to use a separate process, we don't need to do LeakCanary easy analyzer process, right? So do we still have install? Well, there's this one hack that's amazing that Android provides us with, which is content provider. You may know that content providers are loaded before the application class. So it's a common practice. The support library does it. So I'm encouraging everybody to do it. Googlers are going to hate me. Everybody to do it. Essentially, you can create a content provider, and it gets called before the application on create. And so that means that LeakCanary can self-install. Then the no-op artifact was there because we wanted to be able to call LeakCanary.install from the application class, but because we don't need, even in releases, because we don't need to do that, we don't need the no-op artifact. So what's left? This is how you add LeakCanary to your build. Just add a debug dependency, and you're done. Yeah, you can clap. You know, it's pretty good. That one is kind of a smaller one, a minor one. Toggling it on and off was a pain. Now it's just changing. So essentially, it's a Kotlin property that you can update. There's a config object, a config property, and you just change it to another one, or you take the current one and you copy it. So this is how you could say you have a button that says turn it off, turn it on, turn it off, turn it on. Like if you want to turn off LeakCanary for whatever reason. So it should be fairly easy. Did you know that LeakCanary can run in Instrumentation Test? And all you have to do is add a test listener that's coming from a dedicated artifact. It's a different dependency. You can read that on the website. But essentially, it waits for the end of the test, and then it looks for leaks. So it doesn't slow down your test in the middle. It just waits for the end, and it fails the test if it finds a non-excluded leak. So this is an example of a test that's actually in the code. This test is called tu peux pas test because it's a failing test, so it can't really test, and that's what tu peux pas test means in French, and it's also other references that I'm not going to get into. And then you dive into it, and you get a different representation. So this is a new string representation that was implemented by Brendan. I hope it's clearer, because it's very similar to the UI. A lot of ASCII art going on there. And you can see here, it shows next to the text view, it says the view ID of the text view is r.id.helpertext. So that should help you figure out what the problems are. There's many other things that I didn't mention. I'm going to have a really hard time even making a changelog because we just added so many things. One of the things we did is when you look at a leak at a leak trace, I added not me. Colin added a shared to Stack Overflow. Okay, cool. We have 5 minutes. Shared to Stack Overflow button in it. The main reason is that people, and I don't want to blame anyone, but what happens is people will have leaks in their app, and they're going to open issues on LeakCanary to get us to help them fix the problems in their app. And I have time for open source, but not that kind of open source. So we try to kind of say, hey, maybe you should go into Stack Overflow and ask someone else. So we'll see if that works. In the future, we want to add more inspectors and make it way smarter. Maybe someday build a backend to upload the leaks to a backend. In the future, not so far away, this thing is so good, I think, that it could actually run in production, which brings its whole set of problems. But the idea would be that when you have an out of memory error, you could, on the next start, slowly analyze what happened and maybe upload that to your server, and maybe you'll know actually why you crashed and which were the memories used and all that. I can't make any promises there. I haven't done it, but I think it could work, and I do intend to look at it more closely. And then some other things like better control of notifications and that. And so LeakCanary 2 Alpha 1 was released this morning. Please try it out, and thank you for listening. Do we have a few minutes for questions?
2 minutes for questions.
2 minutes for questions.
2 minutes.
Great.
And we can also say about the...
Oh yeah, and if you have any more questions about LeakCanary, I'll be tomorrow at the, whatever the name of that thing where people ask questions. What is it?
the place?
No, yeah, office hours. Go to where the constraint layout thing, and I'm going to be next to them. I'm just squatting and sitting there.
Any question?
Who's going to try it today? No one? Come on. I see a few hands. Okay, I released it. I haven't tested that the release worked. Tell me if it didn't. please tell me. There's a Twitter here. You can tweet at me. You can find any other way. Just talk to me in person. If there's no question, you're welcome to just come to. I'm happy to chat about it tomorrow and hear anything that you find painful or anything that you want to improve. Yeah, thank you for your time again. Have a great day.